Okay, so yesterday we did two questions on triangle. So today we will do, I'll give you one question on triangle and next question on square. Uh, and then we will move to the next concept. So x-axis, y-axis, like you said, we will take x-axis and y-axis in terms of meters and let the charges be placed at point P, point Q, and point R. So we'll take point P as minus a comma 0, point Q as a comma 0, and point R is 0 comma 2a. Okay,
Yes, sir.
most important thing, the magnitude of the charges I'm giving it as same, but direction, sorry, not direction, the sign of the charge is what I am varying. So we have minus q charge over here, plus q charge over here, and plus q charge over here. Find the force due to P and Q on R. Okay, find the force on charge at R due to P and Q. Because of symmetry and stuff, the magnitudes will be same, but the directions is what is changing. So I'll write this is F and this is F, right?
You should take minus, sir.
Hmm?
Minus.
Resultant is towards the minus I cap, and that is, let us say, 2F. Now we have to define our angle.
Sir, I did differently.
I know. So it's okay. I'll take this angle as theta. If that is theta, this is also theta due to symmetry. That means this is 90 minus theta. That means this angle is basically theta. Is this clear?
Yes, sir.
Okay. So
Yes,
this
sir.
is going to be 2f cos theta, and in this case, cos theta is going to be our adjacent, which is A, divided by hypotenuse. How much is hypotenuse?
Root 5.
A root 5, right? So we already know what cos theta is. Cos theta is equal to 1 by root 5, correct?
Yes, sir.
Now let us go for the final answer. What we'll get? We will get vector resultant of all the forces is going to be, magnitude is going to be 2f cos theta, and direction is going to be minus I cap, correct?
Yes, sir.
Now 2 times what is F? F is K, Q1,
Use
Q2. So the charges are same, so Q square divided by
root 5a.
phi A square.
Oh, yes,
Root
sir.
5a whole square. That
Yes,
is
sir.
correct only. Now cos theta is 1 by root 5 times minus I cap, correct?
Hmm.
So we'll have this as minus 2 by pi root 5 aq square by a square times I cap, Newton. Is this clear?
Sir, I took forces are F and minus F, and direction is along minus J cap.
I told you the problem has nothing to do with the Coulomb's law. Most of the students always have problem in vector form So that doesn't mean remove vector form from it, because vector is what makes that solving easy.
Yes, sir.
So, so what here we are actually learning is not electrostatics, we are learning how to implement our vectors,
Yes, sir.
knowledge of vectors, right?
Sir, why can't we do like that? I mean, taking minus f
You took this as minus f
along that side. I mean,
in that direction.
yeah, sir.
Okay, then what?
Then resultant should be, I got f under root 2 of 1 minus cos theta.
You did the a square plus b square plus 2ab cos theta.
Yes, sir.
Okay, let me think about it. So you are saying that the diagram that we will get will be something like this, that there is a force F in this direction and a force minus F in this direction, correct?
Yes, sir.
The minus sign, first thing is minus sign always comes with our direction. Minus sign is assigned to the opposite directed vector, right?
Yes, sir.
So minus sign comes along with direction. Minus sign just doesn't come with magnitude.
Hmm.
So if I say that this is F bar, and if I say this is F bar, then I can say this is minus F bar.
Yes, sir.
Understand what I am trying to say? Suppose I have a vector A bar. I will draw this vector as minus A bar. I will write it as minus A bar, right?
Yes, sir.
But if I am writing magnitude is A, here also magnitude is just A. I cannot write it as minus A.
Yes, sir.
Point number one. So for just a magnitude, I cannot assign minus sign. When I have a vector, because minus sign comes with direction. Minus
Hmm.
sign only comes when there is direction associated. Otherwise, a vector car is moving with 60 kilometers per hour. So if I say 60 I cap, then you can talk something about minus 30 I cap is the velocity of another car.
Yes, sir.
If I just say that speed of a car is 60, then you say speed of another car is minus 30, and then say that I am trying to say that they both are going opposite to each other, then
Hmm.
that is not a complete proper way of putting a vector. Point
Yes.
number one. Point number two, if I say this vector is f bar, how can I say this vector is f bar? Directions are different. Meaning that where I wrote over here f bar and f bar, there only I made a
Hmm.
mistake. I can't do that. I have to write it f1 bar and f2 bar. Meaning that I am also telling about the direction of that particular vector. When we are representing a vector with the arrow above it, we are saying that we are also representing the direction of it, right?
Yes, sir.
So if I call this as f1 bar, then I'll have to call this as f2 bar. This cannot be f1 because this fellow's direction and that fellow's direction are different.
Hmm.
If I call this vector as f2 bar, I'll have to call this vector as minus f2 bar. Only then I can
Yes,
call
sir.
it as minus f2 bar. Now once you come to this stage, then you find the angle between these two vectors. Let us say it is some alpha.
Hmm.
Then I will write the resultant force vector is equal to under root of f1 square plus f2 square plus 2 f1 f2, but f2 is minus into cos of alpha. But I am already making it very, 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 very complicated. Why do I want all of these stories? There are two mistakes initially. I can't assign minus sign to a scalar. Next mistake is if I assign this as a vector, I can't assign this as the same vector because the directions are different. Now, after doing corrections from all those situations, when I come to it, again I am writing a big equation.
Yes,
Question
sir.
number 14. Four charges are placed at the vertices of a rectangle, let's say. Okay, no, I'll give you a square
Sir,
only.
I have doubt from the previous thing. I mean, you're writing 2f cos theta and as well without using the resultant thing. How are you doing, sir?
Without using the square root of a square,
Resultant formula, sir.
without using the square root of a square plus b square plus 2ab cos theta, how am I getting the vector resultant of it, right?
Yes, sir.
So geometrically, I know I have two vectors of equal magnitude, f and f. This much is clear.
Yes, sir.
Now I am using, instead of that resultant formula, after resultant formula, after few lectures, we have done component of vectors.
Oh, yes, sir. I forgot. Okay, I remember. I
So
understood,
if
sir.
I take, so this is how I will begin. Looking at the symmetry of both the forces, I will take this angle as theta. Because of symmetry, this angle will
I
also become.
understood, sir.
No, why I am saying the entire thing is, this way I know f sine theta will cancel each other, right?
Yes, sir.
F sine theta will cancel each other, and I will be remaining with 2f cos theta. Why I am writing the entire thing now is to show you that my choice of angle is also more or less fixed depending on where I am getting my vectors. I can
Yes,
take
sir.
that angle also theta, but why am I taking this angle as theta? So that I get used to the normal 2f cos theta thing and f sine theta cancelling thing. I want to get used to this kind of a situation is all that is.
Yes, sir.
And once this is theta, that fellow is theta. We, in the previous diagram, we've seen it. So using component of vectors, I don't have to use the. So where we have geometrical advantage, we go for components and solve it. Where we do not have geometrical advantage, we go for the square root of a square plus b square plus b.
Yes, sir.
Because in components, I am also covering the direction,
Mm.
right? Minus I cap.
Yes,
In,
sir.
if I go for square root of a square plus b square plus 2ab cos theta, then I have to go for tan alpha separate calculation, b sin theta by a plus b cos theta.
Mm.
Why do I want so many calculations? If we
Yes.
have geometrical symmetry, that is what I mean by saying geometrical advantage. If we have geometrical symmetry, definitely I will go for components so that things will cancel with each other and they become easy. Clear?
Yes, sir.
So question number 14, I will give you square only. So this is our x-axis, this is our y-axis. Again, meter only, no problem with that. So four charges are placed at the vertices of a square of side A. So it is given that this is a square of side A. The charge at point O is plus Q. Take all the four charges are plus Q only. Okay.
Yes, sir.
Find the force on B due to OAC. So we want force on B. Okay. Force on B due to O, C and A. All charges are plus Q. So first I will draw the lines. So due to A it will be along I cap. Due to C it will be along J cap.
Yes, sir.
And due to O it will be along the line joining the diagonal.
And the resultant of both.
And also the resultant. See, this is 45-degree because
Yes, sir. It make 90 better.
so if I call this force of F, this force will also be F, correct?
Yes, sir.
First I will write the magnitudes over here because there is a another charge whose distance is different. Earlier questions, distances, charges, everything was same.
Yes,
So
sir.
we had no problem. But if distances are different sometimes, so we need to figure these things magnitude part first. So I will write F as kq square by a square, correct?
Yes, sir.
Now let me say the force due to charge at O is F1, has a magnitude of F1.
Yes,
So
sir.
my magnitude for that will be F1 is equal to kq square. The charges are the same, but it's just a root 2 whole square.
Yes, sir.
That is basically kq square by 2a square. Or I can say that is f by 2.
Hmm.
Okay, f by 2.
Yes, sir.
See, because of this being a square, I know that the resultant of f and f will also be along the diagonal, f root 2.
Yes, sir.
Can you tell me the unit vector OB cap along that diagonal in terms of I cap and J cap?
Oh,
It is simply I cap
it
plus
will
J.
be AI cap plus AJ cap.
We don't need A anymore. Unit vector. Ah, okay. You can
No,
say AI cap plus AJ cap.
divided by
A root 2
unit. Yeah.
divided by A root 2, which is A gets cancelled and this
A
will be
gets cancelled.
okay.
Yes,
So
sir.
the unit vector from O to B is this. And what is the
Yes.
resultant magnitude that we have? So that also I will figure out geometry stuff from here. Due to these two forces, I have F root 2
Yes, sir.
in the same direction, 45-degree. Because of square, all these things are happening. F root 2.
Yes, sir.
And there is another force F1 in the same
Hmm.
direction, right? So simply you will get the F resultant vector form is equal to, first I have F root 2 in that direction plus I have F1 also in that direction, which is F by 2,
Hmm.
and the unit vector in that direction is I cap plus J cap divided by root 2, and this entire thing is basically Newton.
Yes, sir.
Okay, and F
Yes.
we know is kq square by a square,
Hmm.
so I'll just write it down. So kq square by a square into root 2 and root 2 will get cancelled, it will become 1. This 2 into root 2 will become 1 by 2 root 2, and outside I have I cap plus j cap. This is my final answer. F resultant vector will be this. Is this clear?
Yes, sir. I noted it down.
Done.
Hmm.
We'll do one question. I mean, slightly different. I want you to do it. Just I will change the charge. Same thing, square, I'll only change the charge part. So this is question number
16.
15.
Yes, sir.
Okay. So we have charge plus Q plus 2Q plus 4Q and plus 8Q. Question is the same. Find force on B due to O, C and A. Okay, you got some answer, right?
Yes, sir.
See, this question how I will solve is because the charges distances are same but the charge numbers are different. First let me say that this is force due to A, this is force due to C and this is force due to O. Fine. First
Yes,
I have
sir.
named the forces. Now I will see how the magnitudes will look like. So FA will be K Q1 Q2. 8 twos are 16.
Mm.
Oh sorry, 8 fours are 32. I'll write it.
Yes, sir. Yes, sir.
K Q1 Q2 divided by R square. This is F1, FA.
Yes, sir.
So we can write this as 32 KQ square by A square. Okay, fine,
Yes, sir. Okay. I wrote 16 by mistake. I don't know. Yes, sir.
fine. So FC is equal to, it's okay, your IP is going on. Tomorrow also we'll discuss the same thing. So FC is again K 8Q 2Q divided by A square. And this is 16KQ square by A square, right?
Yes, sir.
Now FO is equal
4
to
root of KQ square by A square.
K 8Q into Q divided by A root 2 whole square.
I took KQ square by A square as P and solved.
Is this correct?
Yes, sir.
A root 2 whole square. So how much will we get this as? 4KQ square
4
by,
root of KQ square by A square.
I don't have any root 2.
Sir, you divide root 2 by 8. I mean 8 by root 2. Wait.
Why should I divide?
I did not take the square of the denominator.
Thank you.
Sir.
Look, look. So instead of, so once this is done, one way is I can take KQ square by A square as F and write this as 32F, this as 16F, this as 4F, right?
Hmm.
But here only I can do something. What it is if I write this only as a vector, I just have to write I cap here.
Yes, sir.
If I write this only as a vector, I just have to write j cap. And if I write this as a vector,
I plus J
I cap plus j cap.
divided by root 2.
Good. You were not sure about this, but thank you. Okay. Now simply my F resultant, I don't have to do much, just add literally whatever is there. One thing is I'll get my KQ square by A square common.
हाँ
In I cap, I have
A2 by
32, and here I cap I have 4 by root 2,
yes sir.
which is 2 root 2.
Hmm.
In J cap, I have 16, and here I have 2 root 2. And J cap, close. That's it. This is my answer in terms of vectors.
Yes sir.
Clear?
Yes sir.
Xerox.